Hello! To celebrate the Humanoid Summit 2025, today we're going to demonstrate our latest humanoid robot risk assessment automation platform here at Saphira. We can get started by clicking into robotics and going to LLM guided onboarding. We're going to provide an image of a humanoid robot that I actually featured in last year's Humanoid Summit talk. So very first thing that's happening on the back end is that we're taking this image and we're summarizing what we see in that image based on what's going to be useful to determine the applicable standards and thus applicable hazards. So we've derived this description and we can start the LLM guided onboarding. So now what the LLM is doing is based on that description and the image, it's answering a whole bunch of questions that it needs to answer to determine which standards apply. Things like, where is it going to be deployed? What kind of environment? What kind of interactions with humans? All the things that you're going to see reoccur throughout our conversation today. And you can see that we're going to apply standards like 13849, 13482, 24028, etc. All right. Now that we've determined those standards and their requirements, let's proceed by taking a look at the hazards that are sourced from one of those standards, ISO 10218-1. Now, this is a standard for traditional industrial manipulators and robot arms, which is something we have a lot of experience with. But why do we apply it here? Well, the reason is because it gives us really good canonical hazards to assess for our humanoid robot. You might say that there are much bigger hazards, but this is a really important starting place. And there are, in fact, a few of these that are specific to humanoid robots as well. But we're going to start by considering crushing, shearing, severing, all the classical types of hazards. And pretty soon, we're going to tune this based on details of our product, including the chemical, the control system, the human factors, hazards, and more. So let's save all of these in the project, and I'll pause for a second while this completes. All right, now that it's completed, we are going to determine the applicable standards, which will just be a matter of matching the earlier requirements into the comprehensive requirements within the Saphira platform. I'll be right back. And here we have it. You can provide additional context if you'd like, but we're really going to save 13482 and 13849 as the key standards that are going to apply for the next couple things you'll see. So we'll set the standards. I'll pause for a second, and we'll proceed to the next step, which is that we're going to have a compliance plan. This is sourced from ISO 13849, and if you were to continue using Saphira beyond this demo, you would actually put together every one of these documents for your final technical file, if you're pursuing CE mark or just going in front of a certification body. All right, so we've saved all of that. Now let's click into the HARA workflow. And the way we're going to start this is we're actually going to start by loading an existing risk assessment that we had produced right there. So you can see that this is a very basic default risk assessment. It's just calling our system generic mobile robot, describing the standards that are there, that are applied. And we have those very high level hazards that were present from earlier, like crushing and so on. So that's not enough. We need to make this a lot more specified. We need to fill in these to be specified. So I'm just going to actually provide Saphira with the same image again. So we'll search for humanoid again, and we'll select the humanoid's title pick, and we'll pause while the system continues and produces the changes we like. Great, and there we have it. You can see that 51 hazards were updated. You can see that our system name was updated, the system description, the operating environment, the system interfaces, all inferred directly from that single image that was provided, or additional technical specs or other customer data sheets that you might have provided to us. Now, the most important piece is that we know to produce an effective risk assessment, we need to really clearly define the system tasks. So that's what's done here. We have a sense of the human involvement, the continuity or frequency of the task, the duration, the system variability factors like environmental conditions, all the important pieces that let us do what you're about to see, which is that we took those hazards like crushing and shearing and so on, and we rated all of them. We determined from that image where in the system they occur. We determined their causes and consequences, and most importantly, we gave them these ratings that let you actually do some really cool stuff downstream. And we justified all of it. We said, this is why these are so high severity. This is really important information if you ever get audited by OSHA, or if you take your safety case in front of an auditor. So to wrap things up, let's scroll down all the way to the bottom. And the very last thing we'll see is what you can do once you have this information, such as you can use Saphira to generate suggestions of all the safety functions that you need to put in place. We can hit AI Generate and take a look at some of that. And here we have it, safety functions like you need an e-stop system that can take activation from a button and de-energize the contactors. Very last thing is you can generate some tests and save the final report.